Right. So let's see how this works, right? Let's see how this works. And input devices. You can see when you input something, for an example, if I type something in my keyboard, it will first go to the memory, main memory. Main memory means random access memory, RAM. So we will learn these components in future, right? So we will learn in details. Today, actually, we need the overview because we are stepping into the new chapter. We need to look at how these components are interconnected, and then we'll learn these components separately in depth. Anyway, inputs, as you said, 8 plus 10 is 18. First, 8 plus 10 will go to the memory and it will send it to the processor for calculations. What is there in the memory will be sent to the processor for calculations. And processor will calculate that. Processor will calculate that. Actually, in addition to this data, it is required to send, so there's another arrow. In addition to this data, it is required to send instruction to the processor. Otherwise, processor will not do the task. So first you have to send, so please draw this arrow, right? This is instructions. You have to send data to the main memory as well as data and instruction both to the CPU. And CPU will understand the instructions and process it. The processed data will be then sent back to the memory and that can be presented back. That is output. Okay, as I said, so is 8 plus 10 divided by 2, subtract 23, multiply by 5, again add 62 or something like that. Big mathematics, some like a longer equation, a longer question. So if it is not fit into the memory, for an example, let's say you have 2 GB RAM. So how many of you are having 2 GB RAM in your computer? Can you remember how many of you are having 2 GB RAMs in your computer? I think most of you are having more than that. Right? How many of you are having 4 GB RAM?
Yes, how can we look at that?
So you can just go to the task manager, right? You can go to the task manager and here, yeah, Dvitika. Yeah, right, okay. Task manager can be accessed by going to, so you can see this is the taskbar. Just right click and get task manager, or you can just give, you can go to the run dialog box, type run dialog box by Windows, go to Windows, press Windows and R button, and that will bring run dialog box. There, please type like this. In run dialog box, type MSINF432 and press enter. Without any spaces, MSINFO32, press enter and you'll get details of your computer.
So what should we write?
MS.
Sir, my computer has 8 GB.
8 GB, okay, good. So MSINFO32. MSINFO32 and press enter. In the press Windows button and R key together, it will display a run dialog box. There, please type MSINFO32 and press enter, and you can see the configuration of your computer. Okay. Right. So let's say you are having 8 GB, and let's say you are having, let's for an example, let's say you are having 1 GB RAM, but still you can play 4 GB movie. RAM cannot keep 4 GB. RAM is only 1 GB, but you can play 4 GB movie. How? Because the movie can be kept in the storage. RAM is limited, but storage is much bigger. So you can keep.
Excuse me, sir.
Yes.
I went and searched the RAM. It says 1 GB.
1 GB, right? Okay. So let's say, so can you play movies in your computer?
Yes, sir.
Possible, no? So, but sometimes movies are bigger, like 2 GB, 4 GB, but still you can play. How? Because you can keep the movie in the secondary storage and play part by part, portion by portion. So that is possible. Right? So movie will be loaded on demand. So something similar to that, you read a large book, which is having like, okay, in this book also, in this your textbook or the workbook, you are having 72 pages. But you are not going to read all 72 pages once. You read page by page. So similar to that, RAM can keep the entire file in the hard disk, then read page by page, load page by page. Similar to that, the movie can be played. Large file can be kept. So that's why the secondary memory is there. So I cannot edit. Oh, right. So it should be but so you can just skip that. That doesn't matter, that because anyway that is a translated word. So you can write it, but the word has that. Yeah, that thing. Okay, so this is called secondary storage, backend storage, auxiliary memory. All these things are given for hard disk, CDs, DVDs. Hard disk, CD, DVD, pen drive, right? So all these things are given to that. Okay, so then, okay, Tanya, you asking about JavaScript. JavaScript is a scripting language which can be used to code web. Right, so that is there in our team programmer. Team programmer, you know, JavaScript, PHP. That is there in the team programmer course. Inulia, what did you send?
Sir, I sent you my memory and other things.
So where? WhatsApp?
Yes, sir.
All right. Okay. Just wait. Installed physical memory is 8 GB. That is the RAM. Physical memory is the RAM. Total physical memory available to you is 4.89 because some part of RAM is still it's occupied. And this is the availability is 1.98 because the other part is utilized for the program that currently running. So this is what page file. Page file means, as I said, that so it has many things. So page file meaning is like in the hard disk. So these pages, similar to this large book, the pages of the programs are kept in the hard disk. This is that file. The size of page file is 6 GB. Hard disk will take 6 by 6 and transfer that to the RAM, portion by portion. That's why that is technical. You won't understand now, but in future, you will understand all these terms. Okay, let's go back. And now you know the process, how it happens. And inside CPU also you have few other components. One is ALU, arithmetic and logical unit. So another one is there.
Sir, what's CACHE?
Cache. You pronounce that as cache memory. So that is similar to a memory inside the processor. Okay, assume that you want to, so assume that for dinner you are going to have bread. So what happened? You will not eat entire bread at once, no? You will take pieces. That pieces are similar to pages that will be stored in the main memory. Those are some slices. You slice it, the bread you have slice it and keep some, maybe 5 or 6 slices. You can keep it in the plate. That is actually to process now. Now you are going to eat that slices. Out of that slices, you take a part of or piece and store in your mouth. That is your cache. Understood? Something similar to that. Inside the processor also there's a memory. Inside your mouth also you can keep some data or keep some facts until processing. So similar to that, inside the processor also we can keep some data, that is cache. Right? Currently processing currently running things are there in the RAM. That is your plate. In the plate you have slices. Out of that slices you take one slice and eat. That is your cache. And out of that piece you divide that into small parts. So in your teeth you do that. That is registers. This is how the processing happens. Okay? Understood my example or not?
Yes, sir.
Okay. What is ALU?
Arithmetical logic unit.
Arithmetic and logical unit. Yeah.
logical unit.
It does the mathematical processing as well as logical processing. Mathematical processing means addition, division, subtraction. So those are mathematical things. Logical means you check whether is it greater than, less than or equal to, greater than or equal to, similar to or not similar to. Likewise, you compare. That is logical. And CU, in the other hand, CU is also a very important component. So I want to add few pencil drawings related to CU. You can add few arrows again from CU to other components. So that is not the same arrow. I'll use dashed arrow, right? Because yeah, I'll use dashes like this in different color. Because CU will pass control instruction from that to all other devices from the particular unit to control unit to all other devices. Control signals will be passed. That's why draw this, right? Control signals will be passed from this control unit to each and every device. It's like traffic police. Traffic police in the junction will instruct drivers to how to drive, but traffic police is not driving. He instructs drivers to drive the direction, this direction, right, left, and stop and turn. Likewise, he instructs the driver. Similar to that, CU is passing. You can use dashed arrows, or you can draw this using pencil in same diagram. These dashed arrows are called control signals. Control signals are passed from the control unit to all other devices. Okay. Please draw that as well. Control unit to all other devices, control signals are passed. Cache means nothing. Cache means a temporary storage. A temporary storage. Cache memory means a temporary or volatile storage. In the actually, it doesn't has mean like ALU is arithmetic, logical, CU control, but cache is cache. So there is a memory. It's a temporary storage. Okay. So these are the components inside the computer. Now you know it very well, and you will get some questions in the examinations related to this, and some questions will be from this area. Actually, write down examples for computer. How do you know that? And you know, so what are the external visible hardware and inside the system unit? What is system unit? System unit is the box, the large box. This one is system unit. Inside that you have hard disk, cooling fan, DVD, motherboard, power supply. All these components are CPU, RAM. All are inside this. This is not CPU, right? Sometimes you in industry or in shops, shop owners are telling that this is CPU. This is not CPU. Inside that you have CPU. This is the CPU chip. This is system unit. Okay, with that I'm going to stop for today. And please go through the videos. I'll upload that. Today video also I'll upload to the Edmodo. Please go through that and do the exams very well. And results we will try to release it within this month, April itself. Because MCQ results you can see that time itself, but there are some structured questions. So that results you won't see that time. We have to look at that, and you will see everything together within this month. That is the first purpose. Okay. Any questions?
Sir, are we having the exam in Edmodo?
Yeah, it will do. Online system.
Okay, sir.
Okay. Then see you all after the new year. Right? Wish you a happy new year. Good night.
Happy New Year,
Thank you,
sir.
sir.
Good night.
Happy New Year, sir. Thank you, sir.
Thank you, sir. Goodbye,
Minulya,
sir. Thank
okay. Minulya, exam date will be the same. 15th, right? 15th will be the exam. I'll share the schedule. Okay.
Okay, sir.